So now I'm going to show how to solve problem 5. Again, try to do that by yourself, especially the distance. I know you guys can do it. And then the low distance, it's a little bit more complicated. Then I'm going to do it for you, okay? So this is problem 5. We have information about the coordinates, right? So I'm going to write here problem 5. We need to know the distance first between A and B. Then we're going to do distance from A to C and then B to C. Okay? So we know the coordinates of A is 100 and 200. And we know the coordinates of B are 400 and 100, right? So remember from the problem here, these are the coordinates that we're going to put in the math, right? So this will be the square root of xa, which is 100, minus xb, which is 400, plus the ya, which is 200, minus yb, which is 100. Okay, and the square root of that. Okay, and here I can put y, where that data came from. Okay, and that is 316.2. Now I go to the distance between A and C. Okay, and then I need to take the coordinates of A and C. Okay, so xa is 100, so square root of 100. Sorry, minus. Oh, then I have to do like this. Minus 100 plus 200, which is ya, minus yb, which is 100, right? Oh, I just forgot to put here the squares, right? You guys didn't told me anything. That's the problem online. I do things wrong, and you guys are not there to correct me, right? So remember that's squared, right? And then square root of everything. And that'll be 100, because basically this is 0, right? And that's a square, 100 squared, and then square root of that. Then the distance between B and C, that's the last distance that I want. So x B is going to be 400. So again, square root of 400 minus 100 plus 100 minus 100, which is 0 again. Oop. Didn't plan very well, but you guys are smart. You guys understand what I'm doing. So, and that's going to be 300. So I have the distance now. Now I need to do the load distances. And the load distance are based in a location. Okay. So for example, if I use the location A, okay, if I use location A, what is going to be the distance from location A to deliver at location A? Well, that's going to be 0, right? So I'm going to calculate the load distance, right, which is L D, to put in location A, multiplying the distance between A and A, in this case will be 0, times the load between A and A, right? And going back to the problem, we have the load is going to be the delivers per day. So it's going to be 0 times 8. Okay? 0 times 8 plus, now I need the distance between, so this is A and A, this is A and B. So if I have something planned in location A and I'm delivering in location B, okay, the distance between A and B is here, is at 316.2. Okay, so that's the having a plan here and delivering here. And then we calculate the distance before, and then I had to times the load, which in this case is going to be 4, plus the distance between A and C, which we have here is going to be 100. So 100 times the load, which is the number of deliveries, and if we look in the data, is giving us 3. Okay, so this will be the load distance, almost outer space, but I can do it. I can do it. You guys can do it too. 1,564.8. Yes, still there. That's the load distance if I put in location A. If I put that in location B, you wouldn't imagine that my handwriting could be wrong, could be worst, but it can be. Okay, paper is actually worse than my handwriting in the whiteboard. So load distance, now I have location A, right? So from B to A, what is the distance? Well, B to A is here, A to B, so 316.2. And then I multiply that by the number of times that I need to deliver A, which is this 8 here, okay? So 8 times comes from the other table. Plus the distance between B and B, and again, we're going to consider that to be 0 because it's the same place, and number of times I need to deliver B is going to be 4, plus the distance between B and C, which is coming back to here, will be 300, and that will be delivered 3 times. Okay, and this will give us the distance of 3,429.6. Okay, last one, location C, the load distance. So now I'm going to deliver from C to A. So C to A is the distance of 100. So 100 times 8, right? Because 8 is going to be the number of times they're going to deliver, plus the distance between C and B, which is 300, times 4, number of times that I'm going to deliver there, plus the distance between C and C, which is going to be 0, times 3, just to put just the times that we're going to deliver there, and that give us 2,000, right? So which location should I choose to put my plant, right? So we need to look at the lowest, right? So the lowest distance here should be the place that I can choose to put the plant. In this case, will be the lowest distance will be location A. Oops, still have it there. Yeah, there it is. It's the best place to put the plant because it's the lowest total distance, right? So that's our answer to the problem. Put the plant in location A. Okay.